Thank you, everyone, for joining, and welcome to Snowflake Office Hours with SnapTravel, the leader in conversational commerce. SnapTravel is founded by repeat tech entrepreneurs who are changing the way travel is booked. They make booking a hotel simple using language processing technology and personalization. Today, I'm joined by Nihal Jain, Senior Data Engineer at SnapTravel. Nihal is responsible for leading and scaling the team that handles all data and infrastructure. With Snowflake at the center of their data stack, SnapTravel has been able to achieve a single source of truth for all of their data, enabling them to make reliable decisions and move the needle in the right direction. Nihal will talk about why they ultimately chose Snowflake as their first data warehouse and talk about the strengths and weaknesses of competitors. My name is Jeannie Liu, and I'm a product marketing manager here at Snowflake. I'll be the moderator for today's event. As always, live questions will be asked at the very end of the session, but please feel free to type them in throughout the duration of Nihal's talk. As always, please ask any and all questions because no question is off limits. Nihal, without further ado, off to you.
Thanks, Jeannie. Do I sound okay?
Excellent.
Okay, awesome. Hello, everyone. So thanks for the introduction, Jeannie, and let's talk a little bit about SnapTravel and Snowflake combined, like how we're using Snowflake. So I want to talk about what is SnapTravel. So SnapTravel is a bot for those of you who haven't heard or used us yet. So we are building a chat bot in the travel space, trying to help people book hotels as soon as they can, getting the aha moment early on in their journey. And right now, if someone has to book a hotel, for example, you have to go to multiple sites and figure out which site has the best rate. Then you have a lengthy checkout flow. What we're trying to do is we're trying to use the elements of a chatbot, which has, speed and intelligence behind it. You can easily onboard people and have quick responses, unlike human agents who have personalization, but there's only a limited amount of service they can do at a given amount of time, and then the very familiar web UI. So it's a right blend of all the three ingredients, which makes SnapTravel. A little bit about numbers and our history. So we are 3 years old. We're still very much an early startup. We are around 150 million in our current run rate, all through messaging. So we are the top grossing bot, which means we make the most amount of money on Facebook Messenger of all the bots that are on Facebook Messenger, for example. We are around 100 employees in the company, just to give you guys an idea of the kind of people working with the data. And why me? So I started very early on. I built most of the infrastructure from ground up and the team, and saw the different challenges as we were growing rapidly up into the right kind of curves for our growth, and how the data was challenged, or the data infrastructure was challenged with it. Of course, data is still very much at the center of all of what we do. So happy to talk to you guys about how Snowflake was really pivotal in how we used Snowflake in decentralizing all the data. We have a team of 4 people, so we have 3 full-time data engineers and an intern, and we were one of the first adopters of Snowflake in Canada when Snowflake came into Canada in 2017, I guess. And so that's a little bit about me. Data needs. So at SnapTravel, we use data in a lot of different ways. The basic one is financials, of course, just to know what our revenue streams are, how we're doing in different markets, all that sort of stuff, what our take rate or margins are, all the analysis of financials. Travel is a very competitive space, so paid marketing is very important. It is very crucial to understand how we're spending money and what kind of conversion and revenue we're making off of that, because otherwise you might bleed yourself to death in the startup world, because if you don't invest your money in a smart way in terms of marketing, then it can be very big sink. Customer experience, so we run a lot of A/B tests. And there's a lot of data, web stream data, clickstream data that is being accumulated, and it gets more complicated because we have, as I talked about earlier, we have a blend of all the three. So we have bots, we have agents, and then the web UI, which is trying to get you the best experience possible. And so A/B tests span from all the way beginning at the messaging stage all the way to the web checkout form. And we combine all of that data into Snowflake for doing the analysis of figuring out how we can do a better job. Supply-demand analysis. So the whole point of why we are so successful is really that you can get a very good price, and that comes by analyzing the supply-demand gap in the market and figuring out where we should focus getting really good rates and where there's a good demand for all these rates. So we do a lot of that analysis. And of course, last but not the least is NLP, which is powering the bot, is powering all the automation of how people chat with the bot, how bot figures out what to recommend, what should be shown to the user first, what is the user trying to say. There's a lot that goes into the natural language processing aspect of the bot itself. And of course, because in today's world we're using deep learning, the amount of data is pretty big that you have to collect and train on, which again is all stored in Snowflake. I'll get into the details of how we use Snowflake in a bit, but these are different data needs. Talking about the different sources, so again, we have quite a lot of variety in terms of sources. So we have structured databases like Postgres. We have structured flat files coming from SFTP from external partners. And then we also have a bunch of different APIs, Redis data, and clickstream, which is all kind of unstructured, high throughput, different kind of volume kind of data. And we aggregate all of that in Snowflake so as to make it single source of truth for everyone to analyze different aspects of the business. So before Snowflake, because we didn't start with Snowflake when we started SnapTravel, what we ended up doing was, or I ended up doing initially was, we used Airflow. So Airflow was kind of mature at that time. And we started saying, okay, we will use Airflow to automate a lot of our jobs. And we started doing ETLs. And with different data sources that kept coming on, we would write a Python script, which would take the data from somewhere, change it to the format that our analysts or business people wanted, and put them in AWS S3, which kind of became a data lake. Not really, because the data set was really small and people would just manually go and download the data and work with it locally. But that's what the workflow was. So whenever there was a new kind of report or new kind of source we wanted, we would go and write the whole DAG, which would fetch the data, transform it, and then put it on AWS. And then people would use Jupyter notebooks or Excel to download it. But because all the data was not easy to find or easy to manipulate, they were also using external dashboards given to us by our partners. So for example, if you're spending money on Facebook, Facebook gave us a dashboard showing how many advertisements we have running at a given time, and then what is our return on ad spend kind of stuff. There were a bunch of different pain points in that. One was there was no single source of truth. So for example, I just talked about dashboards from external people, and then a report we generated from our business logic. They would diverge, and then business people were not able to reconcile why the differences are. Why is Facebook saying that we spent $100 while we say we only spend $95, or we spend more than what Facebook is saying? So all these things were kind of painful. There was no standardization, so there was no standard way or workflow of doing things. So people would just randomly take things in Excel and chart it there and show it to people, or people would analyze something in Jupyter notebooks if they had the skills, and then use that as a way to do reporting, which was kind of painful. Another thing was slow reports. So whenever people wanted to get new kind of reports, they would wait for us to do the whole job, productionize it, and then it was at least a week or two for them to get a report, which they can use to make business decisions. But in such a rapidly changing landscape or rapidly changing business context, so to speak, in a startup, this was not really effective. And then there were data limitations. So Excel and Google Sheets, for example, for business people could only load so much data, and that was not useful. So data teams became the bottleneck very early on. And then we started the journey of figuring out, okay, how can we have data centralized, but also future-proof us in some ways. So we looked at different vendors or different ways of doing this, so to speak. And this is a table which you can find on Fivetran's site, but it's slightly modified for our needs. So we looked at data lakes, relational data warehouses. We looked at Snowflake, BigQuery. These were the main ones. And then I quickly came to conclusion that Snowflake is fitting the bill pretty well. BigQuery was the close second. So let's quickly go through the different features that we looked at. So elasticity was one, which means that based on different computational loads, our warehouse could, or data lake could change and serve us based on the computational load. So things like Redshift, which is an AWS product, which really started the data warehouse revolution in modern stack, has this problem of elasticity being coupled with storage. So you have to decide, or you have to size how much compute you want, and you are stuck to it. And you cannot really change how much compute you're giving to a different query or different types of loads and stuff like that. You'll have to have a separate data warehouse to achieve that. Similarly, for other like relational databases, because they are like a version which was which were not built for that kind of elasticity, this was the problem. And that's where Hadoop came in, which led to all the data lake genre of things where elasticity was at the top. You can really get as much compute as you wanted. You could distribute your load pretty well, and that was something solved by data lake. And BigQuery is very much the same, where you can have elastic compute based on the kind of queries you want and, again, your needs. And Snowflake does that well as well. The other thing was availability, which is based on the infrastructure, how available it is, and how much maintenance work is required to keep it up at most times. So I found that most of the current architecture is really good in terms of availability, except data lake, which requires a lot of tuning going in to keep it up all the time. And we at that time didn't have the resources to really have a data lake running. And it was not fitting the bill in other things, as you can see. Schema-less support was another one of the reasons why data lake and BigQuery got really popular, where they can support JSON, or they can support like basically anything that is nested and doesn't have a schema. BI tooling, so that is what is really required for the business side, where tools like Looker, Periscope, Mode, all Tableau, which is a very big one in the space, they all work off of warehouses, but they don't really have good connection on data lakes. Presto, Athena, all these are changing that a little bit, but still it is a lot of components to do simple stuff. So that's why I didn't like that part of it. In terms of scalability, data lakes are very good. As I said, so for data warehouse, you have to couple it with compute, so the scalability is really not that good. With Snowflake, it's good, but you start hitting limits in terms of slowness of queries if the data becomes really big and you don't manage your tables well. That's something we started experiencing when we were new to Snowflake and we didn't know how to manage our data set. And then BigQuery, I haven't used it personally, but I've heard BigQuery is very good in scaling as well. In terms of maintenance, I don't like maintaining the warehouse infrastructure, and Snowflake was amazing in terms of being a turnkey solution. And Snowflake also gave us transactional, which data lake or BigQuery could not. So these were some of the things we looked at, and happy to answer more questions in the Q&A section. So this is just a summary of that, but one of the things is the last point where because I wanted to make sure that I'm not pulling a trigger just based on ease and it will future-proof me in terms of all different types of requirements, I looked at who else is using Snowflake, and Netflix, Instacart, Hotel Tonight, which is one of our competitors, Capital One, Strava, Amplitude. A lot of people who have massive amounts of data and complexity were using it. So that was good. So this is what our current architecture looks like. We have very much used ELT approach, where we extract and load it into Snowflake and let the analyst and the people downstream manage the context of transformation using dbt. So to quickly go through what we're using, all the relational databases and standard data sources like Facebook ads, Google ads, Google AdWords, all that we use Stitch, which is a vendor which lets you build pipelines in few minutes by just adding credentials and setting a few properties into Snowflake. We have some custom operators written into Airflow, which is another open source tool, which is pretty popular in today's modern data stacks to write ETLs. And we load custom APIs and SFTPs using that. And then we have Clickstream coming in, where we aggregate data using FluentD, which is a daemon which you can run on different clients, which can aggregate data into S3. And then we use a Snowflake feature called Snowpipe, which is a very easy way of piping data into Snowflake from given storage sources. And on the post end of Snowflake is R, Jupyter, Periscope, whatever else. Like, it connects with a lot of different BI tools, so that's taken care of. We are right now onboarding on this new tool called dbt, which lets analysts do transformations easily. So it basically reads raw data from Snowflake and puts transform data back into Snowflake. So that's our current architecture. And so finally, I want to wrap it up and then open it for everyone to ask questions. I would like to stress on these few things. So being a small startup, it was always a question of build versus buy. Engineers love building things, but it's not always the best decision. And for me personally, one of the best moments was when I put in my credentials into Snowflake. I didn't have to do anything else, and the data was ready for me to QA. Like, I can already queue a sample data set. I can load simple CSVs in and then just start playing with the warehouse. Whereas for Redshift, I had to do a lot of work. For BigQuery, I would have to, so we are all in AWS, so our cloud is AWS, so I will have to move a lot of our data into Google's infrastructure, and that is why we didn't really get to play with BigQuery that much. And with Data Lake, we have to set up a lot of different kind of components to really get started. So for us, buy made sense at that point, and we're pretty happy with it. Snowflake worked great for us, as I said, because of how we were growing from 1 or 2 person team to 4 person team, servicing such a big set of clients internally, and the great support from the BI side and also infrastructure-wise, giving us things like elasticity and availability, in the sense that you can separate your storage and your compute. That was amazing. And also giving us Variant, which is a JSON schema-less kind of data type. It works super well. It's pretty optimized, so you can have indexes on it, so to speak, and you can optimize your queries on subfields of JSON. So that was really useful for us. We also future-proofed ourselves in the sense that we checked for things like clustering keys. So can we tune our queries? Can we make people self-serve? And how it can be easily in the center of all of our data, decoupling everything else. The other solution was using Kafka, which is kind of hard to maintain again, but works very well in decoupling producers and consumers. And then the other thing is, if you are building out a new data function or new kind of, if you already have a lot of stuff built in your architecture, then it's hard to go from ETL to ELT, but I would really recommend thinking about ELT and just loading raw data and letting transformation happen after. That has helped us a lot of man hours, a lot of productivity, and in general, better consensus on how the data should flow and who should own what. So yeah, these are some of the thoughts I have around how we use Snowflake and how it worked well for us. I'm happy to hear questions. You can find all the slides here, or you can ping me on email or Twitter on these links.
Excellent. Thank you, Nahil. Very helpful, and really loved hearing your presentation, especially when you talk about the LT skills, the building is super helpful. One of the slides I found really interesting was slide of 9. You looked at the entire range of competitors in those different dimensions. The one thing I wanted to add was, this is great. The one thing I wanted to add was, our biggest differentiator, we view it, is that we're cross-cloud. We're not constrained to one provider, so we have the unique ability to provide a multi-cloud for everyone on the line in FYI. So let's get into questions here. A handful have come in, and I've done my best to bucket them. Let's start off with a couple of questions about performance. We get this question a lot, and the question is specifically about how has performance changed since you moved from an on-prem system to Snowflake, and what are some of the KPIs you use to monitor?
Yeah, that's a good question. One of the things that we closely monitor is IQRT, which is Interactive Query Response Time. And it has been generally very good from the get-go. It hasn't been a problem apart from cases where we have billions of rows being added in a week. So we have some tables which are around, so it's the clickstream data which is coming in because of the amount of events that are happening on the highest point of the funnel in the whole experience. And that data becomes slow to query sometimes, but then we used clustering keys to optimize based on the where clause that we were seeing being run on the data set, and that really reduced the time by multifold. So I would recommend using clustering keys if you are having performance issues. But in general, from the get-go, the performance is very good, and it's easy to look at interactive query response time, IQRT, by looking at the history. So Snowflake gives a detailed view called the history view, where you can query the kind of resolution times or the kind of wait times, different type of metadata for queries, which is very helpful for the data infrastructure people to understand what's going on. Was that helpful? Are there any follow-ups? Jeannie, if you would like to add something.
Yeah. Well, let's get into this question, and then we'll make sure that I think it's a holistic view. So this question in particular was, I would like to understand if you or SnapTravel did any kind of cost analysis before finalizing Snowflake. I want to add in another follow-up to this, which is not just the cost component is important, but you also have the role of the DBA changing. And so I guess my other question would be, how did this really change aspects of the DBA's job, and what kind of skill sets did you look for on top of what you've already been looking for? Just because Snowflake is zero management, so what are some other trade-offs that you have now, not just with cost?
Yeah, that's a very good point. So when I did vendor selection, I looked at a bunch of things. So I really wanted to make sure that we are future-proof. Again, I'm saying that a lot just because I have seen a lot of changes happen in the last 3 years in SnapTravel and hence in the data team itself. And one of the things that from the get-go, which we wanted was not have a DBA kind of role in the team, because that's a lot of operational costs that we might not be the best at. So we like pushing that to Snowflake or vendors who are solving this problem for a multitude of people. That's generally the culture inside SnapTravel, until unless it becomes really expensive. But then on that front, Snowflake was pretty cheap in terms of storage, because it really just passes on the S3 cost. So for us, S3, but on different clouds, they'll use different storages. I was looking specifically for AWS, so I can vouch for that, where we were paying the same amount of cost to Snowflake, which we would if we were paying to store the data on our S3. Now, data lakes were really, one of their boasting points was cost, that the cost is the same as, it's the cheapest way to store data, but then Snowflake was able to match that, so that's not a problem. In terms of the cost of compute, So that was not so bad when I look at flexibility that Snowflake was giving us. So I was really comparing it against AWS Redshift and data lakes. As I said, BigQuery was kind of a different beast, but it has comparable cost to Snowflake. So it's not like we will have it's a huge discrepancy, or you're losing a lot of money in Snowflake versus BigQuery. So that was not the case. So I looked at data lakes and Redshift, and what I found was because I can turn off my compute when no one is querying it, that really saves a lot of money, which I cannot do in other cases. Like a data lake solution might always be running, or it will be instantiated, but then when it's instantiating, running, and then closing down, that's pretty slow. So there are different types of costs associated with running a data warehouse, and sometimes it's not clear what the costs are. The other thing is, the roles. So the roles that we look for are people who can actually, so we don't look for people who are strong on the infrastructure side, but more on the data engineering aspects of handling data, handling change, and creating processes which can span across team, that's what has happened the most after Snowflake came in, that we didn't have to spend a lot of time managing the data warehouse, but helping other teams get their value. And that happened by building self-serving tools on top of it, or just spreading the knowledge of how to use Snowflake and the BI tool together and all that sort of stuff.
Excellent.
And another thing to add here is that we found that Snowflake's documentation is really good. Like, it has been very helpful to just point to documentation and not explain some of the features that Snowflake offers, and it has been huge cost saver.
Excellent. So, Nihal, there's a couple of questions about dbt. And first of all, let's just level set, and can you please elaborate what it is? And the second is, how do you use dbt?
Absolutely, yeah. So dbt is an open source tool. We're kind of still finishing our implementation of dbt, but dbt is a tool written by Fishtown Analytics, which is a consulting company. What they found was they were doing a lot of SQL work for different companies which they were consulting with, or different projects, and they built a reusable set of tools. And it does a bunch of different things, but the whole idea is that you can use Ginger templating, tests, self-generating documentation, and you can have self-referencing SQL in one repo. And dbt kind of automates all of that. So dbt is, dbt is the T in the ELT for us. And they have a really good Slack group where you can just join in and ask your questions. It's a very thriving community. And it was started, I think, a year or two ago. So it's not like it's been there for a long time. That's why people don't know about it. But it has changed the way our workflow works and how our analysts produce their work. You can do everything like materialization, as I said, self-generating documentation, which is huge. You can test your SQL. You can have variety of tests. So some of the tests are given to you as just features. So there is a YAML file which defines the schema, and you can define tests in there, and there can be different types of tests. So you can have uniqueness tests, referential tests. You can have not null tests, or you can have things like this column can only have these values, and stuff like that. And then you can also write just custom SQL and test that. It also helps people, or analysts, so to speak, or people who are doing the T, understand how data lineage flows from the raw data to the report. And if there's a problem, it's easily fixable because they own a lot of it, which was not the case before when we were doing the transformation ourselves. So I propose you guys check it out. I think just search dbt on Google. Their Slack is called dbt.slack.com. Join the community, and you will see people chatting about and asking about what the thing is, how it will help them, and stuff like that.
Excellent. I have a couple of questions that have to do with real-time data consumption. So let's first start off with how much data, or just ballpark-wise, are you storing in Snowflake? And then the follow-up to that is, do you have any, just because of the hotel industry is very competitive, it seems like real-time data is one of your competitive advantages, or would be one for a potential company. What are some of the ways that you're handling both the real-time consumption and the real-time delivery of data?
Yes. Okay. So this is a very good question. I like that the context of travel is also put in there. So yes, there is a lot of data in real time that other competitors are not able to use. Although Hotel Tonight is on Snowflake as well, and I was looking at their presentation and they have something similar on their side, is rates, which is the thing that we are selling. You're buying a rate for a hotel room, expires in a few hours or a few minutes, depending on where you're buying it from. So there are a lot of ephemeral objects that we're trying to store in real time. How we consume it is we have written some internal libraries which capture data from any kind of client. So be it a browser, be it a microservice like server, be it a Lambda function. We stream the data somewhere, and then we stream it using FluentD. And then FluentD stores it on S3, and then we use Snowpipe, which is basically a pipe between an S3 bucket where you're storing all the data, and the destination is a table, and it does so in real time. How it does this is that you hook the Snowpipe onto a notification of whenever there's a new new object that is created on S3, which means there's new data to be loaded. It takes that and then loads it into the table automatically. You don't really have to do much. To give you some ballpark numbers, we're storing around 30 million events in one table, and we have around 12 of such tables. Not all of them have 30 million events, but that's one of the bigger tables we have. We have around 5 or 6 tables like that, and then we have total amount of 12 tables which we have real-time data coming in. And the cost is not really that much. I think it is only a couple of $100 per month to store that, and it has been working very reliably for us. And they have documentation online to set it up. Was there any part of the question that I missed?
That's great. So you talked about the size and how you're using a tool like Snowpipe. A couple of questions as we get into more of the vendor selection piece. So when you look at the project timeline, so from vendor selection all the way to go live, what sort of milestones did you have in place, and how long in duration did that take?
Right. Okay. So that's a very important question to ask yourself when you're in a startup, that how long will it take for us to go from point A to B, because our priorities are changing so quickly. So we built different pieces of the pipeline in different stages. The current diagram that I showed you is not always how it looked like. This is the current snapshot, but this was not always like this. Like DBT is a few weeks ago. We just started a few weeks ago. So it's like really a lot of different pieces are still coming along. But the first iteration was when we got our parity with what is on this slide, where we were bringing all the different data sources into S3. Just bringing parity with this into Snowflake just took us 2 weeks, because it was really changing the destination from S3 to be Snowflake by running a copy command. And that was pretty easy to do, very extensible. There's a lot of community support already. Snowflake has written some code in Airflow itself where you can write a SQL query, and there's an operator which will do all the things for you. So, and because there's no maintenance of setting everything up, we were able to reach parity in 2 weeks. Of course, thinking of the bigger picture and then re-architecting the whole thing took a few months, but that's basically building us for the future self. So we didn't have any event pipeline here. That took around a month, I believe, from thinking about the idea to actually productionizing it. And then productionizing it to the volume that I'm talking about, 30 million views per 30 million events per day. But yeah, it has been pretty swift in general. Snowpipe took us literally a day to set V0 because it is really as easy as running 2 SQL commands. And then there haven't been many issues on that side. There have been some complexity issues on the Fluentd side, but I don't know if we would attribute that to the Snowflake part, but end-to-end, yes, that is one of the complex pieces of our architecture. Where, again, if you have the money for it, you can buy different solutions like Snowplow is an open source solution which can do something similar, and they are integrating with Snowflake this year. So you can use them to do the real-time stuff, or you can use something like Segment, but then you end up paying a lot more.
Yeah, great point. So open source is always an option, but there again, you have challenges with the build and leave mentality. So just a lot of different options out there. Thanks for. I do want to wrap up quickly, but we've gotten a lot of questions about the comparison slide on slide 9. So this one in particular refers to Snowflake as being okay in scalability and BigQuery as being good. So can you add a little bit of clarity around that?
Yeah. So again, I haven't worked with BigQuery myself, but when I was looking at the analysis, many people, there's a lot of discussion around these different points online. If you go and look at different data blogs, people have done the comparison on big data sets. And scalability for us, for Snowflake, didn't work just out of the box, but I've heard that it works well for BigQuery. And because by the nature of how MapReduce works, it works pretty well for Data Lake as well. So there were issues when we had an append-only event table that our queries were becoming slow, and we had to tweak the table properties itself, like adding clustering and figuring out what the best way to do clustering is. Even though that whole project of optimizing a table did not take more than 2 days, but it still wasn't working out of the box, and we had to identify an issue and fix it, whereas BigQuery and Data Lake seems to work out of the box. And they're built for really high throughput on distributed data sets.
Excellent. I'm going to just wrap up with this question because we've gotten multiple versions of this. So you mentioned on your final thoughts where you talked about build versus buy, and you also talked about future-proofing. You also mentioned ELT versus ETL. So these questions, these series of questions have to do with more clarity around that. So why ELT versus ETL?
Yeah, so there are a bunch of problems that are solved by going ELT from ETL. From a personal experience standpoint, we had few problems. Biggest one was ownership. So if we start doing transformations for the business team, what is happening is the context is changing very rapidly, and they want to move that business logic into the transformation. That's where most of the business logic is. And if we do the transformation, then there's a lot of communication cost or overhead required to get that done. But with ELT, what we do is our SLA or SLO for our team is really to just load the raw data in the best and the most reliable format for them to use. And then they can self-serve by doing the transformation themselves. So pushing transformation completely out of the picture from the pipeline has helped us move much faster in terms of ownership and self-serving people. The other thing is also that debugging becomes very easy because you can isolate problems in loading versus transforming. And if it is a problem with loading and your pipeline is working well, it's really the problem with the source. A lot of times our partners don't have good data on their end, which is quite funny, but most of the times the files we're getting on SFTP has been very painful to work with because they have bad data. Sometimes they give us files with just the header and no data. Sometimes they just give us empty files. So there are potentially very weak checks on their end. But if we make idempotent pipelines which can keep ingesting the data when it arrives, then really by ELT, we know that either it's the source or it's the transformation, and we can future-proof or we can kind of make the pipeline robust and work on more interesting things. Otherwise, we are always tweaking the ETL. Also, I think, again, referring to Fivetran's blog, on this, which I read a few months ago, is pretty good. They talk in detail about the cost benefits as well, of how ELT is better than ETL. And of course, just to let people know that because they do a lot of ELT, they will definitely have a bias towards it, but we have found that to be very useful.
Excellent. Thank you so much, Nihal.
Awesome.
So, thank you.
Thank you.
Thanks everyone for joining, and especially to you, Nihal. We'll have our next office hours in 2 weeks, and we'll make the slide deck and recording available to everyone who has logged in as well as signed up. In this slide deck, you'll see Nihal's information. So I know a couple of you have asked directly about his contact. And we'll see you at the next office hours, and have a great day, everybody.
Thanks. Bye.